Okay, so this is session 5, the final one in this. Yeah, I know. Exaltation, oh hi. And we're basically gonna look at expanding what we have right now to incorporate other options. And if you kind of look at your handout, and I'll pull it up on the screen. Session 5. That's fine. What we're going to kind of look at is, well, first of all, I'll just go through what this current block diagram has on it, and then we will continue. So if you watch from the video, you'll see what the program does, but just quickly, I'll go through it now. It looks big and scary, but don't be put off. It's not that big and scary. What we have here is a way of organizing the file structure. And I'll kind of go through it moderately slowly so we can see where things are going. But one thing that you don't want to have to do is every time you run an analysis, tell it where to put every file and which folder to put it in. It's much better, if I pull up the example, so it's much better if we're analyzing, in this folder set. We want the program to automatically know, okay, I need to go up one directory to here. I need to make a new folder here, call it this. I need to make a new folder here, put all my images in there. I need to put so we need to establish kind of a file structure, and that's all this is doing at the start. It's trying to make it easier, so that every time it wants to save a file, it doesn't ask you where to put it. And equally, we don't want to have kind of on the front panel, we don't want to have, like 15 different image input boxes, because it's not necessary. By stating this one, all of the file structure can be established from this location.
So you put every time in the same folder, close to your origin image.
Exactly.
Okay.
So right now, yeah. So we essentially would be clicking on one of these files, and it just puts it in the parent directory. So we make a new folder in the same parent directory, so that they're always together. But we're not writing anything to the folder which has your images in it, to kind of keep it clean. One of the other things that we're going to look at is we're going to use this sub-VI instead of a standard filter, because we're running this pattern filter. One thing that we can do is, if we have a data set which is just numbered, or we want to use all of the files, instead of filtering for like star.ch00.tif, when we select a file, we're then pulling out what this file extension is, and we're then reading that file extension and then padding it, so that our filter is now, rather than specifically entering it, we are writing a little bit of code which says whatever file extension we choose as the image, that's the file extension we want to look at. So if there's like text files or other file extensions, don't look at those. We just want to look at all the JPEGs. Previously you had to type star.jpg, but this is just a little way of not having to do that, because by selecting that file, we are telling it that we want to look at JPEG files. So I'll show you what we're doing here. A lot of this is trying to make at the end of the day, you want to have a streamlined program. You want to have it running as efficiently as possible, especially for analyses that you need to do over and over and over again. And this is what we're trying to achieve by all of this organization up front. The next kind of little block does the image preloader, so we load all the images. But at the same time, we're making duplicate copies, and we're renaming them using the zeropad file name, so that not only are we loading them all to the memory, but we're kind of putting them in the background, resaving them, so that any future analysis or different programs, or if we just want them nicely named for some other reason, this will take care of it at the same time. It's totally not necessary. It's like a personal preference if you want to have it there. We're then doing it the correct way for handling color images. So when you're doing intensity measurements, it essentially is going to look at some pixel value. Each pixel has a value associated with it. Generally 8-bit pixels, 0 to 255. That's what they have. A color image has that in at least 3 channels, sometimes 4 channels. So you need to tell it which channel to look at. Okay. Up to this point, we've just been putting it in a grayscale bin. We've been taking a color image and dropping it into a grayscale bin and calling it good. And for sometimes that's fine. The correct way to do it, rather than actually grayscale an image, is to create an 8-bit image, but by extracting one of the color planes. So we want to look at, if say we're doing it on the confocal and we said it's going to be a red plane, then we'd look at the red channel or the green channel. Or if we're looking at it if we have like an RGB image made from a color camera, we can equally switch this to an intensity plane. So if you kind of look on the front panel, you have a whole series of options for this. It can be green, red, intensity. It could be the pixel value, luminosity, saturation. So these are all different values of colors. So depending on what your data set is, you'd kind of choose the plane which best matches what you're looking at. So that's all this is doing. This is how an extra level of complexity, but this is how you should correctly extract your 8-bit image from a 32-bit image. Then once we've got that, again, we have this standard ROI analysis doohickey. Nothing's changed there. Rewrite the spreadsheet exactly the same as last time. And the only thing that's different is this little section here, where rather than making different color images, what we're actually doing is we're making a little video file. So we're making a video of what we're doing, and to make your guys' life even more difficult, we're overlaying a timestamp. So with a lot of these videos, when you make a video, you need to add some kind of time reference, because it's depending on how fast you play it back, depends on how fast you think it's happening. So if you put a timestamp on the video, you can run it as fast or as slow as you want. You have a reference on every frame, how long it is. Exactly. So putting a timestamp on your images is something that is very common to do when you make videos. And this is a very simple timestamp. We read in how many frames per second we said it's recording. We figure out how many milliseconds that's going to be in the frame. We turn this number into a string. We then add it to this millisecond extension, and then we write it on there. So with a lot of image manipulation, especially for the video encoding, you can put lots and lots of things on top of images. Just like in Photoshop, they're treated as layers. They're treated as overlapping layers. So I could, it's hard to pull out any of the layers, but you can pull out the bottom image. So if I was here and I just said, look, save the AVI, then it would not transfer over any of the overlay data. So we're writing on top of an image, but when you try to manipulate anything with that image, it will just take the image. The overlays are kind of just floating around doing their thing. So what we have to also do that a lot of people don't do is you then have to merge the two. So like a Photoshop example would be you're flattening the image. You're essentially taking all of those layers and squishing them to the background layer. And then when they're on the background layer, we can then write it into an AVI because it's now a different type of frame. And then the best is just kind of cleaning it up. We're just cleaning up the VI. And this is a lot to take in. Luckily, we've done most of it before. What we're going to start off by doing is really just digging down and looking at how we separate out files. Okay, because this is one of the things that always goes wrong, and it will go wrong for you too. Everybody does it wrong. It's kind of like, you know, that whole matrix scene thing. It's like, it doesn't matter. It doesn't matter how good you are. The first few times, if you jump in from one section to another, you're gonna make a mess. And files are gonna be all over the place. You're gonna put files like in root directories. You're gonna write them. You know, they'll all be all over the place. Because these are low level. These are pretty low level VIs. So they don't come with help files. They don't come with, like, you know, user directions. They're very low level VIs, and they allow you to make mistakes. So you will make mistakes.
Really?
Just don't, you know, you're probably going to come to me multiple times and say, look, I'm making this file and I don't know where it's going. And it'll be saving it somewhere really strange. But, you know, we'll figure it out. And then this bit we'll kind of do as well. And then we'll just kind of keep going and see where we get to. What I'm going to do is keep sections of this live right now. And kind of take out, you know, big chunks, so that you don't have to construct the whole thing at once. So what I will probably think we should do, if you guys think the same, is we pick a part and then we rebuild it, and then we pick another part and then we rebuild it, rather than starting with a blank one, because there's not enough time to rebuild this whole thing from blank.
No.
And it's more important that you see how each section is built. Okay?
But can we today, like, you build but I don't build but I take notes?
Absolutely.
You know, after the rest.
Absolutely.
No,
You can
it
just
can be okay?
yeah, you can just watch.
Okay.
And we can see kind of where we get to. There are a few things that you might need to, you know, ask questions on. Like this kind of remaking your image thing. If we actually look in the folder, this is, you know, essentially the renamed original images. Okay. And sometimes, if you are doing overlays or you're working with the data, we're extracting a color plane and we're putting an overlay on it. So if we look at that video again, so the video essentially becomes black and white because it's now an 8-bit image and it's got an overlaid time code. So if I kind of scroll through, yeah, time code just sits there and does its thing. You know, this is now a black and white image with a time code written on it. And sometimes there would be like a desire to have all of the frames for this outputted, but this is just to let you know that there's something that you can do, but most of the times it's not worth it. Is we can kind of write each one of these new made frames and save them as files too. But because here we're not doing any manipulation to the video type, it's essentially a big stack of bitmap files. Okay, these are pixel information. There's no kind of like JPEG smoothing. There's no compression factors or anything. We can add all of that, and it's just a feature of this one. We can just change it and put in different compression filters, etc. Actually, you need to do it at the start. But leaving it as raw as possible means that we never have to save the images, because they're all bitmaps, just a bitmap stack. So we can extract a frame from this video, and it's exactly the same as if we saved the file and the image. You can treat it as, rather than it being like a real AVI file, it's just a folder, you know, that you can play. And at any point you want to extract any frame, you know, you can essentially open up in VDub and extract the frame. You could save all of the frames if you so desired, but what I've kind of learned is it's pointless. Because it's an uncompressed AVI file, it has all of the data in it. There's no point for us to save all of the files too. Saving all of the original files, just rename things, is worthwhile. Because this is your original data. It's good to have it right. But the actual data that we're finishing with, once we have that AVI file, we're good. So just that as a prerequisite. Okay, let's destroy a massive chunk of this VI and then we'll rebuild it. Probably one of the hardest things to get around is this, file naming situation. So I can go through this. What I'm going to do first is rebuild this pathway so that we can see exactly where this comes from, why we use it with these guys, etc. So let me start deleting. So that's a good reason why not to hit Control B. Because if I hit Control B there, then it deletes wires that I don't want to delete. You're best off, figuring out where they are. See, right now I know it's just deleting this section, so that's fine. Now we can wipe this guy out. Okay, so all I'm doing right now is destroying, let me change this, create constant. So what we'll do now, the first thing we'll do is we will come up with our own way to filter the files. Okay, and then down here it's kind of showing you, an idea how we're doing it. But how I've shown you in previous sessions is we create a control on the front panel, and then we type it in here. Okay, we type in the star.jpg, and it would all be good. But a lot of times you don't actually need all of this stuff. What you actually just want to say is this. You want all the files that are JPEGs. Because it's quite common to have, you need all of the files, but you don't want, the text files and the other necessary, like program files, LEI files, for example. So by choosing one of the images, we're already telling it we want JPEG files, okay? So what we can do is we can add that into this, so we don't have to keep this pattern function. So if we go to file input output, sorry, let me show you that. If you go to file input output, and it's actually labeled under advanced functions, and get file extension. Because what we want is we want to choose a file, and we want to get what file extension that file has. Okay, we can do this, and actually in the program that I'm writing for Jan, or I've written for Jan, it does it with my own VI instead of a home built VI. So that we can do this without using this particular function if we so desire. Essentially we need to reverse the file name and then take 4 off it and then look at those 4 sequences. So imagine you've got this name file.txt, but we don't know how big this file name is going to be. Okay, it could be 10 characters long, it could be 100 characters long, we don't know. But one thing that you do know is file extensions only are 3 letters. They only have a maximum of 3 letters. But they can be 2 letters. Okay? So what we can do is take this file name, this one might even be doing it. You kind of invert the file name. No, they're searching for it. You invert the file name so that it runs txt.elif in this example. And then we say, look, go 4 to one side. So then it goes 1, 2, 3, 4. And then you say, did you hit a decimal point? Did you hit a letter? If you hit a decimal point, then the 3 characters before it are the file extension. If you hit a letter, then move back 1, and then the 2 characters before it are your file extension, because you can't be less. You only have 2 choices, 2 or 3. So we can rebuild this very easily, and I do sometimes. But we're going to use this one. So what this wants is, it wants the file. So we have to find where our file location is. Well, we chose our file path here, okay? And then this one is the folder path. So we don't want that one. We want the file path. So that one's down here. So we can just pull wire in from the file path just here. Okay, and then this tells us we have output, so we can look up here. We get a duplicate of this file name if we want it. We get a lowercase file extension. You can ignore that, just file extension. And then we get the file name without the extension. So this is also a way of getting, a file name if you want to get a particular name structure built. But for now, we just need this extension, because that's the thing that we want. File extensions will not have a decimal point in front of them. So a text file is txt, a JPEG file is JPG. So we need to put, if we want to use it, we have to put a decimal point in front of it. So to do that, we have to do what's called concatenate a string, or build a string is another way of thinking about it. So that function is just in the string palette. So you go to the string, and then it's this one. It says concatenate strings. It just means you're building a string. You're adding things together. And what we need to do is we need to take this file extension, but this needs to be the second thing in the string, yeah. And the first thing needs to be a decimal point. Okay, so whatever file extension it finds, we need to put a dot in front of it. Yeah, because that's how file extensions work. Okay, we actually need to do one more thing. If we want to filter this into this pattern, so we can get rid of that now. So if we want to use this file extension as the pattern that we're looking for, right now it'll just look for a file which is only called dot whatever, right? So we need to put a wildcard in front of it so it knows kind of what it's looking for. Okay? So rather than just dot, we need to put star dot. Now it looks for everything with that file extension. Okay, and that's now patterned into there. Everything else will happen as is, but just for clarity, just wire the arrow over too, so that the structure kind of flows a little bit easier. And that's it. We essentially have solved the naming issue. We now only choose files that have got the same extension as the file we choose. Okay, well that one's kind of a quick patch. Now we'll kind of look at where we're going to put things. One other thing while I'm thinking about it. Our ZeroPad file name extension looks for a file extension in it. It needs to know because it builds your own file names for you, it needs to know what you want to call it. So we need to we need to add the same thing up here. And since we're kind of automating these things, we want to, rather than write this explicitly, we want to use the same information that we're getting here. Okay? So we want to duplicate this. So control and drag it. And we need the same file extension. But this time we just need a full stop. So we don't need a star this time. We just need a full stop. Because we just need to write .jpeg essentially. And then we can use that as our file extension instead of writing it. And that again, helps with the automation of things. Just trying to make things run as smoothly and cleanly as possible. Okay, now we kind of got that started. Let's start destroying this file organizational structure. Let me pull some things down so that you know what we're looking at. Okay. So if we just look at these string values for now and before I get rid of them. What we're going to do is we need to make a folder. Okay? We need to make a folder, we have to tell it where to put the folder and what to call this folder. We then need to make another folder, which is where we're going to put all the images, and we need to name that something too. And then we also need to give, well, we don't have to, but it's good practice to give your file names a name before you tag the number on. IMG is just a common one for images, is what they say. We're also making a video, so we need to come up with a video file name and put that somewhere too. So we're doing quite a bit here. So what we're going to do is destroy it all and then rebuild it. Well, let's be really harsh, and then you can see how we fumble along to make it right. You know what? Let's create the end of the world, and let's. So now nothing knows where anything is going. So we have to rebuild the entire kind of file structure. We have a cheat sheet. We know where things are supposed to go, but we'll try and work backwards and then figure out, you know, where everything has to go. Okay, so to start off with, figure out why we're flowing both ways here. That's just because it's not optimized. To start off with, we need to make our analysis folder. Oops. Okay, it's kind of handy to have, you know, a new. Yeah, it wouldn't shock me if somebody called me right now. Yeah, go away. It's good to make, yes, it's good to make a folder where we can put everything. It's kind of like a safe place to put everything. Yeah. So if you right click on your functions, go to File, Input, Output, and I believe it's advanced. We have something called Create Folder. We want to do that. We want to make a folder. Now it's kind of like, where on earth do you want to put this folder? So we need to figure out how we're going to write this file path. Right now this is a path name. So to start off with, we need to find out what the folder name is. Okay? So you go to File, Input, Output, and we need to strip the path out. Yeah? So we're going to strip out the folder name for where these files are. Yeah? Okay, so then once we got that, we now know which folder these files are in. So if we made a new folder now, it's going to put it within there. So an example would be, you'd get a new folder at the top of this list. Okay, we don't want to do that. Okay, we don't want to put anything in this folder if we don't have to. Might as well put it in its parent directory. So this is the same directory, but we need to go one up. Okay, so then we need to do the same thing again. So we need to, so if you hold Control and kind of drag it over. Exactly. We need to strip off where this folder is. So now this tells us where the folder of the folder is, which, you know, it's commonly called the parent directory. So once we know the parent directory, we now need to, just like if we're building a file name, we need to build a path with some name, which leads to this directory. So we go to our File, Input, Output thing, and we need to build a path. Okay? this is our parent directory, so that's still going to be our parent directory. But what we need to do is we need to have a folder name. Okay, if we right click and create a constant, we come up with our name for a lot of things. Analysis looks fine, but this is how you would build a file path. Okay, this is not sufficient to kind of construct a folder. This is sufficient to construct a file name. What we need to do is put a switch on there, which indicates this is a folder. And just like when you're kind of typing out folder names and things, the kind of / thing indicates this is a directory structure. So we put this little directory structure switch in there, and then when we say, look, this is how I want your path naming, it knows that it's not trying to name a file, it's trying to name a folder. And then we build this folder, and now we are making an analysis folder. This is the path for that folder, and that's as simple or as difficult as that section is. We now have our new folder that we can start to dump things into. Okay, the first thing we're going to want to dump in there are all of our new images, because we're going to remake all of our file images. So we want to put things in there, but we don't want to put them in this parent directory. Okay, we don't want to just fill this folder up with all our images, because this is our new kind of nice, happy, organized data folder. We want to actually make a subfolder to put our images in. Okay, so we need to do something a little bit similar that we were doing here. This is now our parent directory, just like this was our parent directory. Okay, so if we want to build another path, so we take this file path, which is the file path for the new parent directory, and we build another directory. So we're going to create a constant, and we're going to call this one image. What do I call it? New images. New images. Okay, and just like last time, because we're going to use this as a file path identifier, we want to put a little switch on the end. So then when we call this, we don't get any wacky errors. Okay, so now we are building a new folder, which is called New Images, which is inside a new folder called Analysis, which is inside the parent directory from where we were. So that's how we kind of build our organizational structure, and we kind of need to go even further, because over here where we're writing, here we're saving we're saving our file names, our new files. Okay, and this is getting its file names from our sub VI, which is putting a zero padding sub VI, but this needs to know where it's putting them. Right now there's no kind of precursor file name. It just has its kind of little zero padded bit to the end. So we need to say what bit to put in front of this zero padded section, and that's what flows into the top of here. So we need to do two things. We need to give it a starter name, so the img thing, and we also need to put where in the world these img files are supposed to go. So we need to build some paths, just like we've been doing previously, but rather than making a folder this time, we're actually going to make an image name. Okay, so I'm going to right click down here and create a constant, and a good constant for images is just img, and to keep things as standard as we can, an underscore after the img before the number keeps things looking good. And we just want to put them in this folder, so we just connect this path into this base path, and now it's going to put img files in this folder. Okay, so this is now our starter. How did I phrase it? our path before the number is added. So this is our starter path. So we need to flow this into our sub VI. So it now knows kind of where it's, this is, just as a reminder, this is taking our path before number is added, so the location we just said. And here's this build string thing again. Okay, this is the build string thing. This, for want of a better word, is just figuring out how many zeros to add on the end. And then at the bottom, it's adding on that file extension. So we have our precursor path, we then have a bunch of zeros, and then we have a file extension. And then it makes it into a path. So that's what we've got here. We've got this new path that we just gave it. We've got our little kind of file extension doohickey, and itself comes up with a number of zeros. Okay, so next section. So we've made a folder. We've made another folder inside that folder for the images. We've created a structure for how to handle the file names. We also need to name the video file. Okay, the AVI file. Oh, just in case you don't remember these steps, obviously nothing's going to work right now because we haven't named some things. But if we click on this, it'll give us some help. Okay, it's going to tell us why it's not going to run. And right now it says, look, whoever made this sub VI said that this has to be wired. If we hit show error, it'll kind of highlight, you know, this point here needs changing, and this point here is AVI. Yeah. Okay, so we need to tell it where to put this AVI. Now, we don't want to put it in the image folder, no. What we actually want to do is put it in our analysis folder. Yeah. So we need to build a path. Well, we can use one of these. So we want to go in this folder. Then we want to give it a name. Now, we can do all kinds of fancy things for the naming, but because we're not there yet, we're just going to give it a constant file name. We're going to like vid. Very simple, it's just vid.avi. We're telling it to go in this new folder we made, and then we're just going to wire that into here. So this one is new to us. This is making an AVI. I'll quickly explain what that does before I delete it all. When you're saving files, so if we're saving images, for example, we just save the image. It's a very simple one piecewise operation. A video is you can kind of think of it more as like a zip file for images. You have to make a zip file, you then have to stick the images in, then you have to close the zip file. It's the same thing with building AVIs. It's like you have to, first of all, write all of the parameters which make up the container. That is called containers. Then we stick everything inside the container, and then we close the container. And then once the container is closed, you can read it. If it's an open container, you can't read it. It'll not work. So that's what we're doing here. And if we scroll through, you'll see each of the 3 steps. So here, we're writing what the container is. We're saying where it's going to go, the AVI path. We're saying how many frames per second you have to encode. We're saying kind of if we want a compression filter or not. These ones you can kind of ignore. They're very specific for certain data types. The only ones that we need to worry about are telling it where it's going to write this AVI. Frames per second is very good to type in. You don't have to, but I would always write it in. And compression, for now, I would choose always just leave it blank. So then you never compress your data. I can show you specific techniques for compressing the data, but for now it's best to not destroy it. So we leave compression data off for now. So here we make this AVI, so we built a container. Then if we scroll over, here we go. So here we're writing one of the frames. So we're putting stuff in the container. And then here we're closing the container. Okay, those 3 operations make up a build AVI sequence. Okay, almost always, well, I shouldn't say almost always when you're building an AVI, you'll be inside a for loop. Because it has to put them in frame by frame. It has to open the frame, has to put it in the container, and then the for loop clicks over, and then it puts the next one in the container, clicks over, puts the next one in the container. You can't just dump, stuff into it. It has to be able to order them in a certain way. So, I mean, it even looks, very reminiscent of like a flip book. I mean, that's kind of what it is. It's like first picture, stick it on the page, next page, next picture, next page, next picture. And then when you're done, you can flick the book. So those three operations make up the AVI. And we've named this AVI now. So let's look at the other options that we have.
So this is just the container.
This is just, yeah. All it is you're coming up with a way of, it's just like an initiation of a process.
Mm-hmm.
We need to prepare the system so that it knows that we're going to make an AVI. Mm-hmm. We don't have to do it here. We can do it, all the way over here. Mm-hmm. We can do it right before it's used. Totally fine. It's just I started it over here. Mm-hmm. We can move it. Makes no difference. Mm-hmm. But those three operations are necessary for every AVI. You create the container, you put stuff in the container, you close the container. So the other things you get to choose are the frames per second. I'm using 10 for this example because the frames aren't running that fast. Normally, if you were doing, like a normal speed, if we're using, let's say, these point gray cameras, you might be running at 20 frames per second. Okay, and if you're doing lots of things with cameras, you probably won't have all this other ROI analysis stuff in the same program. Mm-hmm. You'll have a very small program for writing these images into a video file. And in that situation, you'll probably make this a control. If this is going to be like kind of, if you envisage using, a way to stick all the confocal images together and make a video, it'd be a very small VI to start with, like very small. It'd fit just within this region here. But also, you'd make this a control so you can choose it easily. Right now, I'm just hard coding it because this is for a particular data set, but there's no, if you're making lots of videos, we put this as a control. So what we're going to do is I will delete this. Ah. Like I said, don't hit Control B if you don't have to, because it goes a long way. But because I'm showing you how things work, I will. I'm going to delete these videos too. Time 58. No, I'm not going to. I'm going to show you how we do it. So I'll delete this video. And then this video. Control B that one. Okay. So you notice now that it says it's going to work fine. Mm-hmm. And it will. It's just not going to make a video. Mm-hmm. So what we're going to do is quickly show you how we tack things into this script to make a video. So, like I said, we have to initialize kind of the video, the AVI file. So what we'll do is we'll put it actually over here. So we'll put it right next to it. So if we right click on here, go to Vision and Motion, go to Vision Utilities, then go to Files, and it's in a separate section. Yeah, it's kind of a long way down there. But once you're there, it's fine. There's a lot of things that we can do in here. Just to quickly go through them, the ones that you'll use most often are the Create AVI. So this makes the container. Mm-hmm. Then the Write frame, which puts stuff in the container, and then the Close one. It's all in one nice, neat line. That's what it is. The line below it is if you're reading data from the file. So just like I was saying at the start, if you have an uncompressed AVI, it's just a stack of bitmap files. So what we can do is, rather than having a folder full of images to look at, we can just move data around as a video. You know, we don't have to move the data around as a stack of images. We can keep it as a video, and then it's easier. But in that example, you know, we would have to open the AVI. So this opens it. So finds the container and opens the container. We then read a particular file. We choose which frame to look at, and that's how we do it. And then in that situation, use that one to close it as well. We have these other two little things, and these are information bars. So the get info one, if you're opening a VI, you might need to know how many frames there are in the file. Just in a way, it's kind of like in the stack of images analysis, you know, we were able to know how many files there are if we just wired it up and then read the end value. But that's not the case with videos. We have to actually read the video file to tell us how many frames it contains. And then we wire that into like n, for example, you know, so we could work with it. And the get filter names one is, like I was saying, we can add compression levels and things to the AVI if we want to. You shouldn't for most files, and it's not necessary. But if you have like this phenomenally huge file, you know, it's like 10 gigs or something, and you want to compress it, we have to use some filtering, so compression or otherwise. But each computer has its own set of filters. We can't say use the Lagarith compression algorithm, because not all computers have the Lagarith compression algorithm. So we use this to first of all tell us what filters does your computer have, what compression algorithms do you have. So then that'll give us a list, and then we can choose from that list what we want to do. But in this quick example, we just need these first three: the create, the write, and the close. Okay, so first of all, we're going to create it. So we click on that, put it down here. We're actually going to tell it to do it in between these two loops, because it has to be done before this loop. So we want it to execute after this previous one. So we'll just delete this out, and we'll just wire it in. So this definitely executes before this loop starts. Okay. And like before, we have all these choices. Frames per second one, we're just going to make it constant. So we'll just say it always defaults to 30. We want to run it at 10 frames per second because it's pretty slow data.
What is the quality?
So the quality is kind of like a compression factor. So if you say you want to run like a motion JPEG filter, then there's a quality factor associated with that. If motion JPEG is a good example. Same thing with like TIFF kind of files. You can make a video from a TIFF style compression, and you know, like if you save something in Photoshop, you have the same option, like, you know, how big a file name do you want it to be, and that's the same kind of thing. It's like a 0 to 100 category. You know, 100 being, you know, do the minimum you can, 0 meaning to brute force, make it 1 pixel kind of thing. I would recommend in almost all situations you don't compress. So if you have particular compression needs, we can look at it on a single point basis. But right now we're just going to make this 10 frames per second, and we need to add this AVI path. So we need to wire this to that one we had earlier. So it's one annoying thing is you can't zoom in and out of Labview. There is one zoom level. So if you have to move somewhere over the other side of the screen, sometimes you have to just essentially go for a walk. Where is it? It's over here somewhere. There it is. Okay. Okay, so we've given it a file name now. So we're making this VI, and again, the VI is totally happy now. You're making an AVI file. The AVI file is going to do nothing, right? It's not, even if we put something inside, we wouldn't be able to use it because, again, it's still open.
Yeah.
We haven't said close. So we need to write something. So you click on the write frame. Let me just get rid of those. Come on. So in here, like I said, we're doing this overlay. So we're writing this millisecond timer. And then we're merging the overlay. So on the left side over here is pulling in the data. So these are kind of the raw black and white images that we've pulled in. But what we want to do is making sure I'm pointing to the right now. These are the raw black and white images that we're pulling in, feeding them through, we're then writing, our frame kind of timestamp on there, but then merging the two together, and then we need to use this merged image as our input for our video. So we'll wire that to the image one. Now if you notice, you've got a few options. This AVI ref num, so that stands for AVI reference number. It literally is a number, but if you hover over the create AVI and like over that one, that's the AVI reference number. So this is making the number and this wants the number, so you can do something else, but the easiest way is just to wire them together. Say, look, when I'm making that, that's the one to use. Okay, and then the only other thing that this one wants is to give us an output, essentially. It's writing files into this container. We just need to close this container off now. So we click on close container and put it outside. So you might be tempted to put it inside. Okay, if you put it inside, it'll stop after the first frame and say is an error. Because we're making one AVI file and we want to put things in it many times, and then we want to close one AVI file. So if this is inside the loop, it will close the AVI file on every frame. So we don't want to do that. We want to close it after it finishes this cycle. Okay, so then we can wire, same thing, it just needs to know the reference number of the AVI file it wants to close. So we just connect together the reference number. It's going to break just like a lot of things because we have to tell it to disable the index. So we disable that index. And just for nicety, we can just kind of wire the errors together. Okay. So now it's writing this file, and it's then closing the AVI file. Okay. It's inputting data into this container, closing the container, and then it's keeping going.
Could you just re-explain this part?
Yep. So it's fine. This part is quite complex, and it's not going to be within our time frame.
It's just to do what?
So what it's doing is, if we look at the video, don't play like that. Oh, screw it. Let it play. What we want to do is we want to write a timestamp.
Yeah.
Because it's very handy to have on videos. So that's what we want to construct. So what we have here is the ability to overlay text on an image. But it's just an overlay. And overlays are transient, meaning we can create them, we can destroy them without touching the image. Just like in Photoshop, how we do with layers, we can create a layer and we can destroy a layer without touching the background. And in fact, if we look over here, I actually have a little clear overlay button. Because when we're drawing this rectangle, as it goes from one sequence to the next, if we don't tell it to clear the overlay, it will keep the position of the green box. So we need to tell it to delete that green box every time. So because we can create this overlay, we want to merge these overlays together. Because just like in Photoshop, if you want to treat the image as a whole. And when we put it in an AVI, we want to treat the image as a whole. We need to flatten this image. And we do that by merging the overlay. You can have as many overlays as you want. And there are lots of occasions where I will use like 15, 20, 30 overlays for, text, for lines, for boxes, for data points. I mean, you can have an awful lot of overlays. And then at the end, you merge them all together, and then you can stitch it together in the video. This part over here, all it's doing is it's calculating, what this frame time is going to be. So we have, we've said from the front panel, how many frames per second we recorded. We're saying, okay, we were using whatever camera and it was recording at 5 frames per second. So if we know it's recorded at 5 frames per second, we say that that's what the frame rate is. Then on the back end, it's taking this frames per second. Because in Labview everything's measured in milliseconds, we have to then convert this to seconds, but reciprocal, because we want to know how many milliseconds each frame is. Instead of how many frames per second, we want to know just how long the frame duration is, or the time between frames. We just feed that number in, and then we're turning it into a text, because, well, you can't overlay numbers, you can only overlay text. So we turn it into text, then we overlay it, merge the overlays, and then stitch it together. Some things are very trial and error. Like if we hover over this guy, there's a few options. There's the font style, so exactly what font and size and color to have the text. I still trial and error it. It's kind of like you put in some numbers and see what it looks like on the video, and if it looks fine, it's good. You might need to like increase your font size or decrease your font size, but that's what this box is here. And to get that, we just right-clicked on Create a Constant. So this is the constant value. So then we just choose kind of, and if you hover over things, it'll tell you what they are. So this is if you want to strike out the text, if you want to have italic text, underline text, bold text, size of the font, everything associated with writing something, you can control. Same with organization. The other thing that you have to put in when you're using this VI is the origin. So you have to say, where is the bottom left-hand corner that I need to start writing from? And again, it's kind of arbitrary. It's like, you pick a number that looks about good for that video size. If you're running a 600 by, if you're running like a 480 by 640 video, that's very different than if you're running like a 10,000 by 10,000 image. So if you're running the 640 by 480 video, like 10x, 10y is probably fine. If you're running like 10,000 by 10,000, running 10 by 10 means you're this tiny dot in the upper corner. You actually need to be a few hundred by a few hundred. So there's no like constant value you can use. It's something you just have to put in as an appropriate origin. And then you get to choose your color. But yeah, right now let's just see if it still works. I have no idea. Delete this folder. Just to show you again, that folder currently exists. So if I try to do anything, it'll break. It'll say, the path will be duplicated. It's like, you can't do this. And this is one of the reasons why we're using low-level VIs, is you can't accidentally delete your data. Okay? We're doing a lot of things in here that are, you should always have your data backed up anyway, but we don't want to be running an analysis while we're actually deleting our data at the same time. We want to protect our data, and this is one way of doing it, that these things are set never to destroy your data. So right now we just hit stop. Yeah, exactly. Let me just save this first. I'll close this one because that's going to be used. It might even want me to close the VI. No, let me delete it. But let's see if we can run it, and hopefully, fingers crossed, it still works. Image paths, let's make sure the image path's okay. Choose a nice file. That looks good. Okay. But something is wrong because it's not running. Okay?
Yeah.
So you see why something's wrong?
Yes,
So you can see that it's not working, right? Yeah?
Mhm.
Okay. So when things like this happen, one of the nice things about Labview is we can go to the block diagram. Let's close this and close this. It's kind of like stalled somewhere. We need to find that stall. And if we hit this little light bulb, it'll tell us exactly where it is right now.
But why we don't have error?
Because it might not be an error.
So what is the problem?
I don't know yet. It's most likely,
Don't know.
well, I haven't run the error thing yet. It's most likely stuck in a loop.
So why it's like transparent? It means the problem is here.
Yeah, exactly.
Okay.
So right now you can see the data is running along to here,
Yeah.
and it's feeding this through. So it's saying that if you actually look here, it's saying, look, there's no error.
Mhm.
I'm not seeing any errors in this program, which means it's not an error. It means there's some error in the wiring that we've done, which is it's not bad enough to cause an error. It's still totally fine. It's still a totally fine operation. It's just not giving us the right data. So we need to figure out kind of where that is. And it's most likely in our kind of file operation thing to start with. So we can run a probe here and see what we've got. Okay, so we've got a problem on the input output. So this is where our error is. It's in this. Because right now, this data stream is supposed to be images. Yeah? Okay? And if you hover, while you're in this little light bulb mode, if you hover over the line, you get this little P. Okay? And that stands for probe. Okay, and if you actually watch where these lines are running, it's like shooting across. So you can say, okay, I want to probe what that data is. Like, tell me what's in this data stream. And when it actually runs, it'll change from not executed to executed, and there's nothing in here. These should be images, and there's nothing. So we know that something's gone wrong with telling it where things are, because this is not right. Okay. So we've got a problem here. So now we're going to try and fix it. So we can switch that off and stop it. Then we have to try and fix the problem. And it can be, more or less anywhere.
This is awful. When you don't have the error, it's awful.
Yeah. See, it can kind of be anywhere. Right. So this is where we start like probing just about everything. Okay, we need to try and find like where on earth this error is. It can be an organizational thing. It can be like in one of these kind of places. But to kind of deal with moderately high level programming, we want to if you right click on a wire, we can do what's called create a breakpoint. Okay, you hit set breakpoint, you get this little red dot. Okay, it means stop here. Okay, so that's where we want you to stop.
Step by step and
Yeah.
find where it comes
So
from.
what we're going to do is we're going to watch the data run down here. And we're going to see what the hell's happening. Okay, so it's unlikely to be in this path. Okay, because this path just writes the image files. Okay, this one is the folder for those images, so the problem's not going to be there either, because we're not even to that point. It's not finding the files. Could the problem be in this one? No. because this is writing a folder too. This is all subsequent analysis. So we know it's not in this section. Okay. So we can like leave this entire section out of the debugging because we know it's not there. Which means it's got to be somewhere down here. So let's follow it down. Did it load the image correctly? Well, I don't think it did. Oh no, it did. So it loaded the image correctly. Okay, so it displayed the file that we chose, which means this wire is right. Okay, so this wire here must be right because it's able to display the file that we chose, which means this VI is right. But I know exactly where the problem is. It's right here. No, that's not the problem either. I apologize. This is pointing to the file. Normally the issue is that this is selecting a folder and not a file, but this is selecting a file, so that one's fine. So that's not the problem.
What does that 10 mean?
It's the frames per second of the video file.
There's another one.
Because we used,
minute. Yes.
yeah,
Yes, that one.
yeah. So what else could be wrong? We could have tacked together something over here so that we're filtering wrong. So we could be, so we're going file out, arrow out into there. So we could be filtering our file names wrong. So let's just check. And we can check right here. So let's stick a probe here. So we're just right clicking and putting probes down. We'll put a probe, so that's reading that one in. We need a probe on this one. So this is reading of the file. So we know it's failing on the preloading the images. Yeah. So if we put a probe on that one, we can see, okay, is that file name kind of right? And in fact, that's all we need to do right now. And we can go to our breakpoint. So we can actually see the data running along. Okay, so right now we should be in here. Okay, so we hit the light bulb, it should just be running around this section. Okay, as soon as we release this light bulb, should rephrase that. As soon as we hit here and release the light bulb, it says we hit this breakpoint. So it now stops the VI. Okay, and then it highlights where it was at, when it broke. So it's saying, look, stop on this wire. So it's like, okay, this is where the current VI is if we stopped. So we can see what it's doing simultaneously. So it's simultaneously writing, stripping this path, writing, reading these two paths, and reading this path. And all those things are what it should be doing. Okay? Now if we take the pause button off, it'll then keep going. So it makes this, it writes that. We're just kind of, scanning all of these files right now. It writes those ones. Okay, it's made that file, it's made that file. Okay, I see where the issue is. Now I'm gonna hit pause to see if you guys can see what the issue is.
Where?
So,
Yes, Dr. Jeffrey.
so if you actually look at this, what's this thing supposed to do? It's supposed to tell us the file extension. Exactly.
Yeah.
And what's it outputting?
The output of the extension.
So the file's extension is .844.000.
The what?
So the file extension should be JPEG, TIFF, bitmap,
Yeah.
right? But what is it?
Now it's like this star and dot or dot.
Right, it's 814.000,
Yeah.
which is wrong. Okay,
Mhm.
that's not a file extension, right?
Yes.
No.
So we're looking at it and it's like, why is there a number when I would expect .jpeg or
Mhm.
.whatever? Means we wired it wrong. So if we stop the VI, okay, go to window. Nah, it's not show front panel. Show context help. Hover over this guy. Okay, do you see where we went wrong? So
The
we're supposed to
The lower.
we're supposed to wire in this one,
Mhm.
and we hit this one.
Oh, okay.
Oh, the file then without intention.
So we hit the wrong we hit the wrong switch. So we want to hit this one.
Yes.
So now if we remove our breakpoint, so it'll take you a while before you can see things as quickly as that. You most likely will sit in front of your VI for a few hours before you figure out where the problem is.
Yeah.
Just
Oh my God.
that's what it's like.
Yeah.
It's when you're starting out, it's really hard to see those kinds of things because I'm used to seeing it. If I see, on a file path name dot something that's not a letter, it instantly sticks out. It's like, why is there a dot and a random number? And then you're kind of like, oh, I now know. As soon as I saw it, I knew what the problem was. And those kinds of instant visualization things just come with you looking at it. It's like, it takes you a while before you can just look at it quickly. What you would have to do is do that same thing. Keep the light bulb on and look at each line, probe each line and see, okay, where all the probes are. Because right now, I had a couple of probes active that would have each shown me the same thing just as much. It would say, the file extension is wrong. By probing, I can go over those. By probing these things up here, because the problem, we knew that the problem was somewhere in the preloader, right? Because that was just where it wasn't working. So we just have to start probing like all of these lines and try to figure out where the data is. It's not that bad. There are critical ones, like it's not loading the images, which means it's probably in the file path, right? So you just probe the file path. This is opening the images, so essentially I'd right click and create a probe. So that now when I run it, it's going to show me the file path. And if it's some wacky numbered thing, it's really obvious that there's a problem right there. And you just kind of piecewise go through until you find your problem. Sometimes you need a separate pair of eyes to look at it. Sometimes you need to ask somebody and be like, look at this, what the hell's that? And it can be anybody. I mean, sometimes you've just been staring at it so long you can't see where the problem is. But Labview is, one of its huge benefits is this ability to probe things and get an error. It's not like regular programming where it just says, you have an error. It actually lets you try to find it. So this way we'd be able to find it. You would be able to find it, Celine.
So it's good to create some sub VI, so make it a complicated program is the simple one.
Mm-hmm.
Yeah.
It's different parts.
Mm-hmm. So now we're free run it. So if we run now, and we choose whatever, pick an image.
Okay.
Ah,
This,
there's a problem.
Now it's working.
So it needs some experience.
It's a little bit of experience. It's just a little bit of perseverance. It's just like, I didn't know where the error was.
Yeah.
I had no idea. It was like, it's got to have something to do with opening the files because it was failing at opening the files. So there's only so many, like I was kind of showing you, on this top, let's just finish this first, red 5. Oh, it's still open. I'll let continue.
But why at the beginning when you run and you see just this part transparent, why it's not, or at the beginning, because it was like, I think in this part, when it was the error, but we didn't know, and it was running, it was transparent here, I think.
Only there. Yes.
Yeah, only there. But why it's
Say that
not,
again.
The first time you're running,
Yeah.
and it didn't work,
Yeah.
you just saw that it was transparent here.
It was transparent here, right?
Yeah.
Yeah, it's because it was stuck.
Can be stuck before,
Well, no, because I hadn't hit the ROI OK button. It's told to be in here, okay? So until I hit that ROI OK button, it'll stay in that loop. I mean, if I'd hit OK, it would have run to the end and there'd just be nothing saved.
Yeah.
Because it's still doing exactly what we told it, but rather than it analyzing the region of interest of images, it's got no images to analyze.
Mm-hmm.
So we're not, in here we actually don't set any hard numbers. We're not saying do 10 images or do 5 images. We'll just say do as many images as you find. And it didn't find any, so it wouldn't do anything.
Yeah.
If we set a hard number in there and say do 5 images,
Mm-hmm.
then it would fail and say there's an error. Which, because it would say, look, there isn't 5 images. I don't know how many. It's like I can't run round 5 times because there's nothing there. I mean, like I said, you're gonna have to watch it a little bit.
Mm-hmm.
Yeah.
One thing that I just noticed is we didn't wire up this guy, so we'll wire up this guy too. So we want to put this in this directory. Like I said, so right now we're going to have, but we're going to have a text file randomly in the root directory called data.txt
Mm-hmm.
because we didn't tell it where to put it. And like I said, you're going to make files all over the place. It happens, especially when you do stuff like I did, which is just delete my entire structure for the files. It happens. But now if we, quickly rerun it again, we should make sure we get that file in there too. So the reason why it was stopped is because we didn't hit this button before. You have to hit that button to make it keep going. So we wired them as user inputs, so just to show that it keeps live. And then it writes a little video. And there should be no errors, and it should just stop. There we go. And then we should have this folder, and it's got all 3 things in it. This has data in it. This has images in it. And our video has an overlay on it. Okay, so we're half an hour over. Happens sometimes. So I'll let the other guys in, and that will be the end of this course session. Are there any questions?
I would like that I didn't get really this part of it.
Yeah.
I
So
don't understand.
Let me quickly.
Because for me, my extension is JPEG, so I don't understand this part.
Right. So, but how does the program know your extension's JPEG? Okay, we're telling it to store. We're telling it to filter these files.
Mm.
Okay. So let's the confocal software is a good example for badly managed data. That it
But in
puts
this case-
all the images and the LEI file and the text file
Yeah.
and everything in the same folder.
file. Yeah, yeah.
Yes.
Okay, so if you actually wanted to analyze that data set,
Mhm.
you have to tell it to filter.
But in this case, what is the point to do this and not to put like channel 00? For example, when you want to filter on
So-
confocal, you can make this pattern. So
Yeah.
I don't get the difference. Or what is the
Because a
point?
lot of times it's not. This is an alternative way of doing it.
Okay.
Not all times do you need to specify what your filter is.
Mhm.
It's just, I want to pick a file, and whatever type of file that is, that's my filter.
Mhm.
But you shouldn't have to say, by actually choosing that file, you're essentially already telling it what the filter is.
Mhm.
So, it doesn't want you to explicitly say, look, star.jpg, because it already knows when you chose that file that you want to filter JPEGs.
But this is because in your file everything is JPEG that you put just this extension.
Yes.
If it was mixed, you cannot.
If it was
Make
mixed
a
of
pattern.
JPEGs or text or whatever, then that works.
Mhm.
Because it's applying the JPEG filter to that set. The thing it doesn't work for is if you want to filter for a file name. So if you want to choose like this channel CH00,
Mhm.
it won't do that. But if you've got a folder filled with JPEGs and GIFs and bitmaps and text files,
Mhm.
it will only pick the ones which have the same file extension as what you chose.
Mhm.
So I mean, if I if it opened up any speed, if I in here just like threw a bunch of random files, so let me just. But instead of them being this, we're like, alright, you could be a dot .yi,
Mhm.
yes. You can be a dot text file. You could be a dot, pick around thing, AVI. And you can do a dot .lei. Alright, so badly file structured data would look like this, where they just threw it all in one bucket.
Mhm.
Kind of like how I am with my desktop.
Mhm.
Throw it all in one bucket and I'll fix it later.
Mhm.
For handling complex large data sets, it ain't the best way to do it. It's much better to separate out your data from your images from your analysis. That's just because you want to keep them in the same parent folder, but you don't want them all stuck in the same folder, just
Mhm.
written. So if this is an example of your data set, then if we chose, let's delete the analysis file. So, we've got all these random files here, okay? By choosing this file, we're saying only use JPEGs.
Mhm.
That's the only prerequisite we have on this data. All we're doing is saying that these are the files, ignore them, because
Okay.
they're not .jpegs. That's how certain programs output the data. They're stuck it in one folder.
But this is because of this?
Yes.
Okay. But why? Well, yeah, I know it's stupid, my question.
No,
But
it's
why
fine.
this dot as just star dot? They will recognize that it's just JPEG. I don't get it.
So, what's happening? Let me stop
You
this.
put a dot for the eye or
No. So, what's happening is
the extension.
This-
To get an extension.
this is reading this file. Okay,
Yeah.
we give it a file.
Yeah.
It tells us what that file name is.
Yeah.
Let's just assume it's this. Let's call it file.txt. Okay.
Mhm.
Then what it's doing is looking for where this dot is.
Yeah.
Okay, and then in this top line, it's telling you what's after the dot, and in this bottom line, it's telling you what's before the dot.
Yeah.
Okay. And if it's telling us what's after the dot, then if we put star dot in front of that, it means everything, all the text files, star dot txt.
Mm-hmm.
Okay. If we, you know, if this was a JPEG file and it had file.jpg, then this would be star.jpg.
Mm-hmm.
And then our order sort filtering thingy requires any kind of filter. You write what your filter is. You know,
Mm-hmm.
normally you'd choose star.jpg or star.tiff, etc. But we're programmatically writing that. We're saying if you chose bitmap files, this filter is bitmap. If you chose TIFF files, this filter is TIFF. If you chose JPEG files, this filter is JPEG. It's reading the file extension for the file you chose and using that as the filter.
So if you click before on this VI file and not on the JPEG file, he will read just
VIs, yeah.
okay, okay, I get it.
If you clicked on the LEI, then it would just look at LEIs.
So it's just because of this VI.
Yep.
Okay.
We are selecting because
one and that's it.
because not all the time do you have. I mean, apart from the confocal, there are very few other instances where you actually have to like filter out based on file name. Normally, you just have to filter out based on extension.
Mm-hmm. But this it cannot work if I choose the channel 0 on
No.
corner because it's not extension.
No.
It's okay.
Yeah.
This you put a pattern to filter.
You could do an explicit one, or you
Mhm.
could just make an add-on to this.
Mm-hmm.
You know, you could add it on, and like on the front thing, you say. We could even write it all very explicitly and just have a little up-down button for saying, look, which channel number, you'd choose 1, it would then make its own string, build that into the string name, write that into the file name, and then use that. So that all you would then use is have a little control up and down thing to choose what channel you want to look at. And again, that would be better than actually explicitly typing the switch. Because as we've seen from the other sessions, if you forget to put the star, or if you have the dot in the wrong place, or, I think all of the previous sessions have shown that on multiple occasions, explicitly writing the filter gives, I'd say, 25% of the people a problem. But if you had a simple up-down number for choosing channel number, then, it's way simpler. You're much less likely to create errors. You'll get errors at this point, because, you'll have things wired together wrong. But as soon as it's wired together right, you won't ever have that same kind of like filtering errors.
Okay. Okay, thanks.
Okay? Any other questions quickly?
We need to do it after then.
Yeah, you do.
Okay.